Hi there, my name is Marcel, and I'm gonna talk about DVC today with you. So, currently, I'm an early stage researcher at the Curie Institute in France, but before, I also worked at LAIS, which is a laboratory for healthcare innovation in Brazil. Even though it's located inside a university, it works in a very industry oriented way. So, we have developed devices and software and done some data science projects and analysis for the Ministry of Healthcare in Brazil. So for almost 8 years, I worked there and worked with machine learning and artificial intelligence and software development, so many things, but always related to healthcare. So I have a computer engineering degree, a graduate degree in big data, and a master of science in bioinformatics in the Federal University of Rio Grande do Norte in Brazil, and now I'm doing a PhD in bioinformatics at Sorbonne in France. And I'm the DVC ambassador now, so I'm very happy to talk about DVC to you today. So, the point is life can be hard. So, if you work with data analysis, at some point you may probably you caught yourself in the situation where you don't know which version of maybe software or data set or the picture. I mean, you don't know which version you used. In this picture on the right, we have last week, but last week usually you can remember. But sometimes, like last month, last semester, last year, and then things are a bit more complicated. If you have several documents or data sets or whatever called like budget estimation 1, 2, 3, okay, that's fine. I mean, at least you have some ordering, you know what's the latest one. But then you generated a picture, you have a plot that you generated from your data set, and you don't remember if it was in your raw data set, it was in your preprocessed data set, was it in your raw data set but with the script that uses the normalization X or the normalization technique Y or Z. So so many things can happen between the data set and your final picture, plot, document, metrics, model, whatever, and sometimes it can be very tricky. Mostly if you're trying to reproduce something that you've done 6 months ago, 1 year ago, and if it's a friend of yours trying to reproduce your work, then it can really be hell. But at least we have the data. Sometimes we lost it. So like in here, the person accidentally deleted another page of his manuscript, but it could be just a data set. Oh, I thought I wouldn't need anymore the raw version of my data set. Now I do. I have to try a new normalization, and I don't have it anymore. So if you are not tracking your data set, you have an issue here. And even if you have all the versions of your data set, all the versions of your source code, all the output files, you can still feel lost because, as I said in the previous example, maybe you do have your plot, you do have your script, and you have your data set, but you don't know where this plot came from. Was it with the raw version of the dataset, preprocessed, which normalization? So many things can happen between the plot and what you did before. And then even if you have everything, if you don't have your pipeline, your experiment being managed, you have an issue. So the thing is, does it have to be like this? I mean, clearly not. But I mean, what are our choices? So right now we have DevOps and MLOps and DataOps and all these things. So we have knowledge from other fields that we can bring to machine learning, we can bring to data science. So the content is there, the knowledge is there. But it's not so easy. So sometimes what we are looking for are tools that can do that for you. Or maybe not do everything, but create an environment in which it's easier for you to add the new things that you are looking for. And you can think that, okay, Git does that. Maybe Git is enough for you. Maybe you think Git solves all your issues. But is it enough? And for code, I would say yes. So for tracking code, I think Git is pretty good. But it's not only about code. And even if you say, oh, but then I can also version my data. I can use some extensions that we have to use Git to version your data. Because as you probably know, Git was not developed to version objects or data sets. it gets really slow if you keep adding data sets and big data files to your Git repository. But then you can try an extension. In the end, if it gets really big the way we have today, very like bigger and bigger data files changing, and then you have your data set, you have a preprocessed version, you have a future version, so you have a lot of copies that are very similar. And if you don't have garbage collectors, for example, to make sure you're not having exact copies of part of your data sets all over the place, things can get really dirty. But even so, even if you have something to do that, it's not only about data versioning. So as I've been saying in all these examples, data files, they are connected to scripts that are also connected to output files, to plots, and all these things. So you also need to manage that. So it's not only about source code versioning or data versioning. You also need pipeline management and even pipeline versioning. So if you don't have experiment or pipeline management, you can be really in trouble. In the same way that your data and your code changes with time, your pipeline also changes with time. So you need to version your pipeline also. So one example that I have, during this COVID-19 pandemic, a lot of people have been trying to analyze data. So basically everyone wants to analyze COVID-19 data. If you go to Facebook or LinkedIn, Medium, any social media, you're gonna see a lot of people just trying to analyze COVID-19 data. And they think they can help, they want to be helpful, so they do that. But sometimes, they are not really analyzing anything, not really seeing anything. Usually they have too much focus on epidemiological data, and that's a bit misleading because in the end you can be comparing oranges and apples. So if you're comparing the epidemiological numbers of San Marino and China, they are very different. So in area, for example, in number of inhabitants and number of medical doctors for every 100,000 citizens, inhabitants, you really have to take into consideration a lot of other things. So in the end, when you're only focusing on epidemiological data, you're going to have a lot of confounding, a lot of selection bias in all these things. So I was thinking about this issue, and I thought that maybe we could do a bit better. So I discussed with a few friends, and in the end, the result of this discussion was these two data papers that we published in Data in Brief, which is a data journal by Elsevier. So the first paper was called the dataset for country profile. So we wanted to get as much data as possible about countries, put them in one dataset, and then give them for people to analyze. So in this one, we had mobility data, epidemiological data, socioeconomical data, political data, ecological data, expenditure from the government in healthcare and in the research, the number of medical doctors for every 100,000, all these things. We did some feature selection, feature engineering, we got them together, some pre-processing, and then we shipped them so that anyone can use. And the second one was to analyze the papers, the scientific studies that have been published so far about COVID-19. So the questions that we had it was clearly to us that people would have if they saw our work, and it's the questions that usually we have when we look at people's work, is really about open science. So how transparent is this study? How reproducible is this study? Can I get more updated data? Because for COVID, for example, we published this paper a few months ago, and we have a lot more data now. And even the data from the past, it's been updated, it's been fixed, some errors have been corrected, some misreporting and all these things. So we wanted us to be able to easily update the dataset, and also that in case we didn't have time to, the user could update the dataset. So we wanted to go from a common black box to a really white box, where the user and the reader would have full knowledge of everything that we did. And we found DVC an amazing tool to do that. And we tried DVC. We used DVC to analyze our data, to do all the pipeline management and everything else, and it worked pretty well. And it's not only about DVC, so it's an ecosystem. Usually you have so many tools that you like and you use to do your data analysis, your DataOps. So usually what people do is that they're gonna use Git to track the code, the source code, and they're gonna use DVC to track data sets, the output files, and the pipeline itself. But you're not limited to that. You can add other tools that you want. So maybe you don't like about this part of Git or this part of DVC. You can just get other tools to do that. So you could add CML. So you are free to choose your tools. You can use CML to do continuous machine learning, CI/CD for machine learning, and then you can use this other tool because you think this tool makes something better about Git or DVC. You know, DVC is not a code that you write inside your software. It's agnostic to that. So if it's it could be R or Python or Ruby or anything, you can use DVC with that. The same way that you can use Git with that. You're not limited to GitHub or GitLab or anything like this, so it's really agnostic. So let's do some hands-on for data tracking. So at this beginning, I'm not doing any data tracking at first. I'm just creating a folder. I'm going to use git init to initiate this folder as a Git repository. In the same way, I'm going to do a DVC init to initiate this Git repository also as a DVC repository. I'm going to do some commands in R just to do a few things. I'm going to commit that. So far, no data tracking. So one thing that I think it's nice to point here is that the same way that you do git init, you do DVC init. This is something that developers of DVC have thought, and I think it's a great idea. So Git is pretty famous nowadays. Everyone knows at least the basic commands of Git. And if you know that, you're good to go with DVC because a lot of commands, they're just the same. So it's git init, DVC init, git add, DVC add, git pull, git push, DVC push, DVC pull. You're gonna see it's very similar. So now we're gonna start doing our data tracking. So I created a text file, a README, or it could be a script or whatever, and I'm gonna use git to add that because I want Git to track that. But then I have this raw dataset file, which is huge, and I don't want Git to track that. I want DVC to track that. And then I'm going to use DVC add, and the name. When you do that, DVC is going to create a DVC file about your dataset, a metadata file. It's a very tiny data file, but it's going to have some metadata like checksum and things like this about your dataset. That's how DVC can, for example, know that if the file changed, and also tie that to the Git commit, so that if you travel in time, you use Git checkout to go to another version of your repository, the data sets are also going to change accordingly. And then you're going to do a Git commit just like you would do a DVC commit. So these commands that you keep repeating, you can also use DVC install, and then whenever you do a Git pull or Git push or things like this, automatically in the background, DVC will also be run. And like in this example, we're going to use git checkout to check out to a different version of this repository. Maybe I want to know how this repository looked like a year ago. And if you type this command, the git checkout, the source code files, the scripts, they're going to change and look like they used to look a year ago. If you type DVC checkout, you're going to change also the data sets and the output files to the way they looked a year ago. So as I said, the same way you do git push, there's an equivalent DVC push. Git pull, DVC pull. So even though it's not mandatory, you can have a Git remote, like GitHub. It's like a remote copy of your repository. In the same way it's not mandatory, it's the same way for DVC. You can have a DVC repository, and it doesn't have to be a GitHub, or it can be anything. An S3 bucket for Amazon, Microsoft Azure, Google Cloud, Dropbox, SSH, or external hard drive, anything you want. And it's not mandatory. I mean, if you want to have a DVC repository. So when you do a git push, Git is going to push your code and some metadata from DVC to your Git repository. And then a DVC push is going to send the data set, the output files, the big files, the object files to your DVC repository, your DVC remote. So here you have the workflow of DVC or of any machine learning project. It's not always like this, but in this example, we can think it's a pretty common example of a machine learning workflow. You're going to have some script to download your data, and then you're going to have the data there. You're going to have the splitter file, which is going to split your data set into training data and validation data. And then you're going to have another script, which is going to run some algorithm. And here it's decision tree, but it could be any algorithm. This algorithm is going to generate a model. And then you can use another script called evaluation to evaluate this model, evaluate the metrics, And if you don't like it, you're gonna run everything again. You're gonna tune your algorithm, change some hyperparameters, see again and again and again. At some point, you're gonna like the metrics or no. But if you do, you're gonna save this as your model, and then it's done, let's say. So let's do some hands-on again, but now with pipelines. So as I was showing, you do DVC add to add a data set. It's going to create this DVC file. It's also going to create an entry at the git ignore file with the name of your new DVC file. That's interesting because if you have a file in your Git repository and Git is not tracking it, a lot of times Git's going to warn you saying that this file is untracked. And you know it's untracked. You don't want Git to track it because DVC is tracking it. So by automatically putting your file in the git ignore, DVC is making Git ignore that file, and then it won't complain, it won't warn you. Then you're going to start creating stages for your pipelines. So in here, I'm going to create a preprocess stage. I'm going to use DVC run to create this stage. And the most common parameters are the -d for dependencies and the -o for output files. So this stage, what we're going to tell DVC to do is that we're going to have dependencies, which is the data set, the simulation.tsv, and the preprocess are the script is going to do the preprocessing. These are the dependencies. If these two things, if any of these two things change, we know that this stage must be run again. And then we're going to generate an output file, which is a preprocessed version of this data set. And what's the stage supposed to do? Run the preprocess.r script. When you do that, you're going to add your git ignore file, your preprocess.r file, and actually here, instead of preprocess.dvc, it should be the dvc.yaml. It's a mistake in the slide. In the past, it used to be like this, but now you're gonna have, if it's 1.0 or later, the DVC version is gonna be the dvc.yaml file, and then you're gonna do a git commit just like you would do in any other project you have. But then I want to create a new stage. And in here, it's gonna be calling another algorithm to work on this preprocessed dataset. And maybe I want to create a new one, which is the final one. And you can keep creating stages of your pipeline. And in the end, if you want, when you create this stage, DVC also runs it for the first time. So let's say that you have run everything, but at some point you change your dataset or you change some parameter in your algorithm. You want to do something like this. And then you can just call DVC and say, DVC, reproduce this pipeline. It's the repro command. And you're going to call the final or any stage, and DVC is going to run up to that stage. Then you can ask, but Marcel, I just changed the last stage. I don't want it to run everything again. And it never does. If DVC realizes it didn't change, it won't run. It will skip that stage. And in the end, that's what I did with the first paper that I mentioned of the datasets. So in here we have in green the script files, in light orange the datasets, in strong orange the stages. So I have this 30 on the top right. We have 35 datasets from the United Nations, and we're gonna call two scripts. One script is the aggregate UN data from the generate single UN dataset stage. And that we're gonna merge all the 35 UN datasets in one single dataset in a specific format. And we're gonna do another stage on the right, which is gonna generate a raw dictionary, data dictionary. With this UN dataset, this merge, along with all the three datasets, the Johns Hopkins University COVID-19 dataset, the Google Mobility dataset, and the ECDC COVID-19 dataset. So ECDC is the European Center for Disease Control. With these four datasets, plus a preprocess.r script, these are the dependencies of our preprocessing stage. And then we're going to run that, and we're going to have the DIB dataset, the final dataset that was published in the data paper that I mentioned to you earlier. Then later, I did what we thought at the very beginning that would be very interesting, that people could update the datasets. So I created on the top left a new stage called update datasets, and I created a script which is check underline update.r. So this script, it checks for new versions of the dataset, and if there are new ones, it's going to download that and then call the preprocess stage. And with that, we're going to rerun everything and have the most updated version of our data in brief dataset. One interesting thing about machine learning or data science is that from a certain perspective, it's metrics driven. So differently from this software development environment where you're always changing a lot of code and stuff, in here, you're not really. You have your code, and actually what you keep changing several times is the parameters, the hyperparameters. You're turning your algorithm, you're tuning it. So you just change a few things here and there, running everything again, and seeing how the metrics changed. And you keep doing that. So you can see that at least at some point, it's metrics driven. And then you can do that with DVC. So in here, we're going to create this new stage called evaluate. There are some dependencies, and this parameter minus m. So the minus m parameter in DVC run, it tells DVC which file it should consider a metrics file. And that's interesting to use the metrics command of DVC. So in here, after you run this stage, you can run DVC metrics show, and it's going to show the information inside this metrics file. And here it's the AUC, the error, and the true positive rate, the number of true positives. Then you can tune again your algorithm, change a few things, and you run it again. And then you're going to type DVC metrics diff to see the difference. So this is very interesting. You see the difference comparing now to the last run of this experiment. And you know, just like you do with Git branches, you can do experiments with branches too. So you could have a few friends working with you on the same experiment. So you think that the best way to improve the metrics of your algorithm is to tune the L4. So you create a branch for that and you keep testing. But your other friend thinks you're wrong. He thinks that increasing the beta is a better choice. And the other friend thinks, no, let's change the alpha. So you're all working with that. At some point, you will indeed find that you have the best model. Then you merge that back into master. And just like Git branches, you can just leave the branch there, or you can delete them. I think it's nice to leave, even if it's like failed experiments, I think it's nice to leave them there, because you know, at some point, like maybe a year later, someone may ask you like, okay, but did you try to increase the beta? And you're like, I don't really remember. Or maybe how better was tuning L4 compared to increasing beta. You know, so I think keeping the failed experiments is very nice to know, to keep the transparency and the history of your projects, to make it everything really transparent. So I think this whole thing, this whole talk is about open science, or doing like an open box, a white box machine learning data science projects. So reproducibility, transparency, all these things are very important, and I think DVC can help you with that. So thanks for your attention. I hope you enjoyed the talk. If you want to get in touch with me through my website, there are contacts page there, or my Twitter, feel free to send any question. So thank you very much for your attention.